Hello everyone, welcome to Concerto. My name's Adeline, and today I wanted to explain how planar magnetic headphones work in a way that non-engineers can understand. I know that it can get pretty complicated with all the blah blah blah, magnetic fields this, current that, so I just wanted to make a little video that explains it in a way that non-engineers can understand. So this video is going to come in two parts. Part one will be basic definitions and explanations just for different terms like what is current, magnetism, and also explaining how sound works. So if you already know those things, just skip to the timestamp that I'm going to put on the screen or in the description. But if you don't know, that's okay. I'm going to explain it in a way that should make sense. So let's get right to it. Alrighty, so let's start with how sound works. Sound is just a pressure wave traveling through air. You can think of air as a bunch of little balls just suspended, right? And whenever you push the air, it'll cause some parts of the air to bunch up, and because it's bunched up, they're gonna push against each other, and then that's gonna lead to another part that gets pushed outwards, that's sort of separated, and then it's gonna get pushed inwards and separated, and it keeps going like that until it reaches your ear. Your ear has a eardrum that can detect these pressure waves as vibrations, and you hear it as sound. Now you may be familiar with seeing noise in this form, right? This is a different form of wave, I forget the exact name, but it's just another way of representing the same thing. Sound is a pressure wave, and how a speaker works is that it creates pressure waves. That pressure wave travels through the air, hits your ear, you hear it as noise. So, let's move on to some basic definitions. Electricity and magnetism are really two sides of the same coin. A lot of the time when you have electricity somewhere, you have magnetism. And a lot of the time when you have magnetism somewhere, you have electricity. So very, very, very outside of the scope of what I'm talking about here, but like they're kind of the same thing in two different ways. Anyways, so we need to understand how both electricity and magnetism works in order to explain the operation of planar magnetic headphones. So the first term you're going to want to know is what current is. Current can be thought of like the flow of electricity, to keep it simple. It's sort of how much electricity is going through at a certain period of time. You can think of it as like a current of a river. A river with strong currents has a lot of water going through it, but a river with a very weak current doesn't have much water that's actually flowing through. They can both have the same amount of water, right? But the current is how much water is going through. Now, important to know is that current also has a direction, right? So you can have current that goes one way or the other way. It's directional, right? Upstream, downstream, like a river. Now, the next thing is magnetic field. A magnetic field, to put it simply, can be thought of as the strength and direction of magnetism, right? So if I were to put a magnet inside of this magnetic field, right? The closer these field lines are, I kind of drew a little, but it'll actually start separating out. The closer these field lines are, the stronger the magnetic field, which means if I were to put a magnet in there, it would react more strongly. It would like get pulled more, right? And what's also important to note is the direction, right? For example, these arrows here indicate what would happen if I were to put a compass inside of this field. Right? If I were to put a compass right here, it would point this way, and then it would point this way, right? Very important to know. Now, that's all the basic terms that you need. Let's move on to planar magnetics. Now, I know this looks bad, but I only put this equation here if you want to look it up for yourself and understand it. But basically, all you need to know is that this physics equation turns into this, and then this turns into what I'm about to explain to you. You don't really need to understand the math, but if you want to, go ahead. I can explain it in the comments. Anyways, so what this equation tells us is that magnetic fields, current, and force have a very special relationship. Basically, what it's telling us here is when you have two, you have the other, right? And it's in this orientation, all right? So we call this the right hand rule. If you hold out your right hand like this, your middle finger is the magnetic field, your thumb is force, and your pointer finger is current. What this says, right, is if you have two, you have the other, right? So for example, if I had a magnetic field going this way and a current going this way, that means a force would be produced on the thing that's carrying the current in this direction. Woo, 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 right? This is the foundational principle by which planar magnetics work, right? What you do is you send a current that's going this way through a little piece of copper, and you also have a magnetic field that's going across it, right? And that generates a force. Yippee! That creates headphones, right? And that force then moves the diaphragm, of course, and that diaphragm moves the air, and that creates the pressure wave that goes to your ear. So typically, how you see planar magnetics arranged, right, is like this, where you have these kind of like zigzags, traces that are going in zigzags, right? And then you have a magnetic field that goes across those zigzags, right? And it's kind of hard to visualize like this. So here's a little thing I drew, right? This is sort of a side view of the magnets, right? And you arrange them in such a way that their magnetic fields are always going horizontal, right? And if we were to kind of turn this into a 3D thing, you would make the electricity go through here in this direction, right? And if we do the right hand rule, middle finger, electric field, right? Pointer finger is the current, thumb is force, right? Now, this is all cool. This means, hey, if we have a current flowing through a magnetic field, it creates a force. Now, you may be asking yourself, aren't circuit boards rigid? That is the special part of planar magnetic headphones. They are built using flexible circuit boards, right? They're all plasticky, right? And that means when there's a force generated on it, they actually bend. And that bending moves the air. And that moving of the air creates noise, right? So I have a pair of planar magnetics to show you because I know that it's hard to look at this. Here are a set of drivers from some Hi-Fi Mans. Sorry, I forgot to undo a screw. Anyways, here is a set of drivers from Hi-Fi Man. So as you can see here, we have traces of copper. So you have current going this way and that way, this way and that way. And here you have an array of magnets, right? Now these magnets are oriented in this fancy little orientation. And that makes it so that you have these magnetic fields going across these lines, right? And because it goes across these lines, it'll generate a force up and down. And as you can see, when I touch this isn't like a solid piece of like whatever. It's flexible. It's like a drum. If I put it up to the microphone. So by running a current across these magnetic fields, it actually generates a force. And that's how planar magnetics work. In summary, current goes this way, magnetic field goes the other way, creates a force, it's flexible, moves, makes noise. Thanks for watching.